everyone, and welcome back to the Smart Tea podcast, where we talk about the lives of scientists and innovators who shaped the world. I'm Aarati.
And I'm her mom, Jyoti. And both of us would like to wish all of you Smarties a very, very happy new year.
Yes, happy 2026.
Yes, and I hope this 2026 is a fantastic year for all of us who are science nerds.
Yes, I always say I hope that this year is better than the last, which is always a true sentiment, always striving for improvement and to be better. But especially so this year. I feel like 2025 was a hard year for a lot of folks. And so
Yes.
Hopefully it gets better.
I think we are off to a good start because I was just looking at the amount of rain. We have been completely rained out this holiday season. So I was trying to find crumbs of comfort because we didn't get to do any of our hikes or anything like that. So I thought,
yeah, we had such great plans for the winter break.
Yeah, we were really thinking that we would be doing a lot of hiking, but we chickened out because it would be all muddy and sliding and we didn't want to injure ourselves.
Mostly we just didn't want to give Cairo like 3 baths.
Yes, absolutely. Yeah. But on the plus side, California is practically without any drought regions right now. So, which is one of the very rare occasions that happens. So, happiness.
And rain is supposed to be a great blessing in Indian culture as well, right?
Absolutely. The Lord is showering us with blessings as we enter the new year. So, we cannot complain. Gratitude all the way.
And in other good news, it is our 50th episode. So it's a very special episode this time. And I was looking for somebody that I could do that was worthy of number 50. It needs
They're
to be
all
someone
worthy scientists, though. They all worthy scientists.
True. Yes. But it was really tough to find somebody who I was like, okay, this will be a really good 50th episode. And I finally landed on a scientist named Dmitri Mendeleev. He is a chemist, and he was responsible for organizing the elements into the periodic table.
Oh, this is a nice big one.
Yes.
One of those huge organizational ones, the ones who set the stage for the rest of us mortals to actually have structure as we try to navigate chemistry. Oh my goodness.
Yeah, so I'm excited. But before we get into his life, I just want to go briefly into the history of the elements and what people thought elements even were, and how we even got to what an element is, which set up Mendeleev's organizing of the elements.
Yes.
I got a lot of this history from a book called Mendeleev's Dream by Paul Stathern. He's written quite an extensive book on the history of the elements and chemistry leading up to Mendeleev.
Would that be more like a before and after?
It's mostly before. There's 20 chapters or something, and 18 of them are before Mendeleev, and then the last 2 are Mendeleev and his organization.
I get it. Okay.
So I'm just going to really quickly summarize, the first
because I can sense that itself could become an entire episode by itself.
Oh.
And
absolutely.
We don't want to get into one of those part 1, part 2, part 3s again.
Yes. I was like, we're not doing that.
Not for a while.
Not doing that again.
Not for a while. We just did the thermodynamics one.
Yes. So I'm just going to quickly just summarize the big main points of his book so that we can set up Dmitri Mendeleev's life. So he starts in ancient times, like 500 or 600 BC, when people were debating which one element was the fundamental element of the world. So some people thought that everything was fundamentally made up of air, or other people had an argument for water. Some people thought fire, and they're all making these different arguments for why they think it's one or the other.
Yes.
Then in the 400s BC, a philosopher named Empedocles said, why do we have to pick one? Why can't we have multiple fundamental elements?
Okay.
And he laid out 4: earth, fire, air, and water. And this remained the prevailing theory for centuries, many, many centuries. And it even got integrated into the thinking of alchemists who were really the first true chemists because they were the ones who first started to understand that by taking certain raw materials and combining them in specific ways, sometimes with even the help of a catalyst, so they understood about catalysts and how they helped chemical reactions, they could get a new material.
Yes.
Obviously, the most notable example that we have for alchemists was turning some base metal like iron or lead into gold. That's what they were all trying to do.
They were all trying that. I remember that. Yes.
But they were also working towards making medicines and obtaining purified metals of other kinds. So
yes,
they were doing a lot of things. Then scientific progress slowed down through the Dark Ages. However, here's where we did get the first mentions of the Philosopher's Stone.
Oh.
Yes. It was a ruby red stone, supposedly, that could turn metals into gold or silver. It could produce an elixir of life that cured all diseases and ailments and extended one's life. And it could even, in some cases, grant spiritual enlightenment.
Wow, that is amazing. I really don't want to go off on a tangent, but just very briefly, ancient India, 5,000 years ago, or even earlier than that, in the Vedas, ancient India laid out 5 elements. In addition to earth, air, water, fire, there was also space. Space was considered as an element. So
interesting.
Everything, I can go off on tangents here a lot. That can become a 1-hour thing. So I'm going to just stop right there.
But that's really cool. Yeah, it's really interesting that they didn't consider space for some reason, I guess. Most of the Western scientists or alchemists at this point.
Yes. I tried to hold my tongue there, but then once you said spiritual enlightenment, I was like, oh no, it's intertwining too closely and I couldn't keep my lips zipped anymore.
Well, that's okay, because I'm about to go off on a little tangent because the thing that I didn't realize was I've first heard about the Philosopher's Stone, obviously, from Harry Potter. That's the name of the first book, right? Harry Potter and the Philosopher's Stone.
Yes.
In the UK, that's what it's called. Here, it's the Sorcerer's Stone.
That's right.
But in the books, the stone did exist, and it was created by a French wizard named Nicolas Flamel in the 1300s. And apparently, this is based off of a true person. There was a man named Nicolas Flamel in the 1300s who was really an alchemist in Paris, who many believed had actually succeeded in making the stone.
J.K. Rowling was very clever about these things. Everything had then her names and all of her allusions had a different connotation. Very often there was a hidden connotation to many of her names, many of her jokes. She's a wonderful writer.
Yeah, I just never knew this. I didn't I don't know why I never realized that he was actually a real person.
Yes. The more broader your worldview, the more you appreciate her subtleties.
Yes. So slowly, alchemists started to create and understand different materials, and these new materials that they were studying didn't quite fit into this 4 fundamental elements idea. Most obviously, there were elements like iron, lead, tin, zinc, and copper that all had different properties.
Yes.
There were acids that seemed to have different strengths. Some were mild, like acetic acid or lactic acid, and some were really strong, like sulfuric or nitric acid, and they could corrode other metals and other materials very quickly. And slowly, they also began to realize that even the air itself could have different properties.
Yes.
Some air was combustible. Some air that came from fermenting liquids had a really strong, pungent smell.
That's right.
And there were scientists who did experiments that collected air from on top of burning charcoal and found that you could not burn a candle in that air.
Wow.
Yeah. So
very cool. The depletion of oxygen was captured in that kind of an experiment.
Yeah. So they're starting to realize that
air is not just a homogeneous entity. It is a mixture of gases. Yeah.
So you can't just say air or just say water, because acid is clearly not water. You can't just say
Correct.
earth because copper and iron have very different properties.
That's
So
right.
rather than thinking about things in these four fundamental elements, scientists or alchemists start to realize that it makes more sense to think about the different states of matter, solids, liquids, and gases, which is what they
Mm-hmm.
knew at the time. And then these things can have different properties depending on what the actual substance is.
Correct, correct.
And then scientists also realized that they could create vacuums where no matter existed, not even air.
Yes,
So I guess
yes.
that would be space that the ancient Indians
Absolutely.
already knew about.
Yes, absolutely. Ancient India had all of these thought processes in place. Yes.
Yeah. But a major breakthrough came in 1661 when
Hmm.
Robert Boyle published a paper called The Skeptical Chemist, where he proposed that since water, which is a liquid, could be evaporated into water vapor, which was a gas, that liquids must be made up of small particles that separated when they were heated.
Good thought. Okay.
Yes. And then by extension, if liquids and gases were both made up of particles, then solids probably were too.
Correct.
He was therefore the first person to define an element as a substance that could not be further broken down into a simpler substance.
Okay.
This paper, with its name, The Skeptical Chemist, also marks the point where alchemy kind of officially drops the AL at the beginning of the word and becomes chemistry.
Chemistry. It becomes a real science now. It's kind of gaining credibility as a science.
Yes. With this new definition, now people really start to discover true elements as we have them on the periodic table. So they didn't often know that they had discovered an element because they didn't have all the tools that we have today, like spectroscopy and stuff, to prove it.
Yes.
They were basically just like heating things up or pouring acids on things until it didn't look like it was going to break down any further. And then they were doing tests for consistency, like they were looking for, does this thing have the same melting point or same boiling point,
Yeah.
the same density across all these different trials that I'm putting it through. And then if it did, then it was considered a new element.
Okay.
Then in the 1790s, an English scientist, John Dalton, proposed atomic theory, which stated that all
Hmm.
elements consisted of tiny, indestructible atoms, and each element's atom had a specific atomic weight.
Next step. Okay. They're
Yes.
slowly building. Hey, this is so cool to hear about the foundations of how the elements were organized. This is very nice.
Yeah. And so now finally the stage is set, and we can get into today's biography about Dmitri Mendeleev.
All right.
So Dmitri Ivanovich Mendeleev was born on February 8th, 1834, in a town called Tobolsk in western Siberia. He was the youngest of 17 children. I know.
Hmm.
14 of which survived long enough to be baptized. And those numbers do differ slightly depending on the source, but 17 children overall seems to be consistent.
Those were tough times, men for women.
Yeah, it's
Hmm.
about to get tougher. So his father, Ivan Pavlovich Mendeleev, was the headmaster of a local high school or
Hmm.
gymnasium, as we've talked
Hmm.
about.
That's right.
However, the year Dmitri was born, Ivan went blind, and so he couldn't work anymore, leaving the burden of
No.
taking care of all the children to Dmitri's mother, Maria Dmitrievna.
Wow. Wow.
Yeah. Maria came from a family of merchants, and her father had started a glass factory
Okay.
and Siberia's very first printing press in Tobolsk. At some point, the glass factory had been abandoned, but Maria, now with an army of kids to feed, reopened the glass factory to start
Hmm.
generating an income.
Wow. She's quite an entrepreneur there. Okay.
Yeah.
Hmm.
She
Hmm.
also set up a church near the factory for the workers to attend and a school where her children could be educated.
Wow. Oh, lady. Oh my goodness. In
Yes.
addition to giving birth to 17 children, she's got all this extra energy going on. It's like I have to feed them, I have to do all this. And so she doesn't do anything by halves.
Yeah, gets it done. Initially, Dmitri did very poorly in school.
Hmm.
Most of his classes were learning about Greek and Latin, which theoretically was the basis for understanding deeper philosophical concepts that shape society. But
Yes.
Dmitri was like, this is all elitist nonsense. I'm not interested. Luckily for him, though, his education was supplemented by a private tutor named Basagrin, who introduced
Hmm.
Dmitri to science.
Ooh.
And soon it became clear that Dmitri was actually a very bright kid, and he even started to do his own little science experiments.
He had a different bent of mind.
Mm-hmm.
He was not interested in philosophy, he was interested in practicality.
Yes.
Hmm.
So I like that. I was like, oh yeah, he was failing Greek and Latin just because he wasn't interested in it
He
all.
didn't see the point of it. It's like, what
Yeah.
am I doing here? Yeah.
However, in 1847, when Dmitri was 13, his father
Hmm.
passed away. And then the next year, the glass factory that had been providing Maria with an income burned down.
No way. Oh my goodness. So sad.
So by this time, only two of the children were still dependent on Maria, Dmitri
Okay.
and his sister Elizaveta. So there was nothing really left in Tobolsk for them anymore. So Maria
Hmm.
decided that since Dmitri was showing so much promise academically, that he should
Hmm.
receive the very best education possible.
Nice.
And that meant traveling to Moscow to hopefully enroll him in a university there.
She is determined. She's got a fierce spirit.
Very determined because Tobolsk is about 1,400 miles away from Moscow. And the only way to get there is to walk, basically.
Really?
They did hitch rides on wagons when they could, but otherwise, Maria, who is 57 years old at this point and has two young kids, they made the journey basically on foot all the way. There's no train, there's no
Mm.
airplane, there's no cars. There's no
Wow.
other way for them to get there.
This is amazing. Amazing
Crazy,
story.
right? Crazy.
Absolutely. Yeah, I would have been crying down on the side of the road somewhere.
I know. I
Or of
know.
like, hey, this school is good enough for you. Go here. And if you want to, you can go by yourself to Moscow later when you're 18.
Yeah. Enjoy. Yeah.
Wow. Wow.
Yeah. So they make this journey. They finally make it to Moscow, and Dmitri, with the help of his mother, applied for entry into universities. But he was rejected everywhere because the universities mostly only granted admission to local students.
Okay.
And so they didn't recognize Siberian school credits. He lived too far away.
Oh,
Yes. I can't imagine. You travel all that way, you get
seriously.
there,
That's
and
very
it's
sad.
like,
That is really, it's like a big blow.
but Maria didn't give up.
Wow.
She took Dmitri and Eliza and traveled a further 400 miles
Ooh.
to the city of St. Petersburg, where Dmitri's father had studied.
Ah, some kind
Yes,
of, hopefully some sort of connection, some sort of a recognition, like, hey, yeah, we know these people kind of deal.
exactly. And again, here, Dmitri was rejected from the University of St. Petersburg for the same
Mm.
reasons.
Oh
But
no.
like you said, Maria did find an old friend of her husband, and he managed to pull some strings and got Dmitri a spot and even a scholarship at the Maine Pedagogical Institute.
Wow. Oh goodness. After all that, she kept going until got something, got him into a school.
Made
Oh
it
my,
happen. Would not let his talent die.
that's
Yeah.
beautiful. Wow.
Very sadly, though, within weeks of Dmitri being accepted into the school, Maria fell ill with tuberculosis and died.
But at least she knew that he was set on a good, right path.
Yes. Years later, Dmitri dedicated his doctoral thesis to her, saying, quote, conducting a factory, she educated me by her own word. She
Hmm.
instructed by example, corrected with love, and to give me the cause of science, she left Siberia with me, spending thus her last resources and strength. When dying, she
Oh.
said, be careful of illusion, work, search for divine and scientific truth, end quote.
Oh, wow. This is deep, man. This is so deep.
I know, a mother's
this is
love.
a mother's love. And also the message that she gives at the very end of her life is the most profound message.
Yeah.
Beautiful.
A year after his mother's death, his sister, Elizaveta, also died of tuberculosis.
I was about to ask what happened to the sister, because now she's what, like 13, 14 years old at this point, and she's
She'll be a
basically...
little bit older. So Dmitri is the youngest, and if he's old enough to go to university, that means he's at least 15 at this point. So she's probably maybe
a
17.
couple years older, let us say, yeah. But still, that's so young. And I was in the back of my mind, as soon as you said mother died, I was worried about her. But okay, she also died. Very sad.
Yeah.
Very sad. So all his older siblings have gone off and set up their own lives, and parents have gone. The only sister who was close to him is gone, and now he's basically an orphan for all real purposes, because the rest of his family is still back in Siberia.
And that's exactly what Paul Stathern, the author of that book, Mendeleev's Dream, said. He said Dmitri was now an orphan adopted by science.
Oh, this is so deep and profound. We are starting the new year with such deep, sad concepts, but very, very, oh my goodness. It fills the heart. It fills the heart.
It really does.
Yeah, it tugs at the heartstrings.
However, Dmitri's health was also declining, and he was also diagnosed with TB. Doctors said Dmitri had barely months left to live. Dmitri continued to study, becoming fascinated by chemistry. So even this death sentence hanging over his head doesn't stop him. In 1855, Dmitri graduated at the top of his class and qualified as a teacher.
In spite of having TB, or has he overcome it?
Well, you'll see. So he was given a position in the city of Simferopol on the Crimean Peninsula. Supposedly, he was given this position because the warm weather was thought to be good for the health. But Paul Stathern thinks that something more nefarious was afoot. So many historians say that Dmitri was a very emotional man. He was prone to losing his temper, but then calming down just as quickly. Apparently, in one of his outbursts, he yelled at the Minister of Education, who took offense and made sure that Dmitri got sent to Simferopol, which was right in the middle of the Crimean War. So when Dmitri got there, he realized that Simferopol had been transformed into an army camp, and there was no school for him to teach at.
Oh, I see. This kind of politics is always detrimental to science. This is terrible.
However, there was one bit of good news. He got checked out by a doctor at the military hospital who told him actually that he wasn't dying. You'll be fine.
Okay. So maybe because he was young and strong, maybe he was strong enough to recover on his own. He waited. It's a bit odd, but...
Or maybe it wasn't quite tuberculosis. It could have been...
Maybe it went into latency or something.
Yeah. So Dmitri, of course, was thrilled.
He's got a new lease on life. Yeah.
Yeah. So he returns to the University of St. Petersburg, and he got a teaching position there, which relied on the students paying him for his lectures because he wasn't getting a job from the actual university. The university was not paying him a salary. And he was also able to continue with his research using the university labs.
Yes.
However, St. Petersburg was not a very happening place for science at the time. So in 1859, Dmitri got a grant to travel for 2 years and study abroad. He first went to Paris, where he studied under Henri Renaud, who discovered that absolute zero equals negative 273 degrees Celsius.
Oh, the connection between the two. Okay, yeah.
Yep.
Okay.
And then he went on to Heidelberg, Germany, where two scientists, Gustav Kirchhoff and Robert Bunsen, creator of the Bunsen burner.
I was about to say that.
Yes.
Yeah. Wow. We are just going right into all these fantastic names that are household names today. All right.
Yeah. And they're all living at the same time and doing their work.
Amazing. What amazing times for science.
Yeah. So Kirchhoff and Bunsen had developed spectroscopy tools that could be used to
Oh,
identify new elements.
we are getting into that now. Okay.
Yeah. So basically, their discovery was that when you heated an element, the light that it emitted produced its own unique spectrum. So
Okay.
each element had its own unique kind of fingerprint, so to speak.
Yes.
So Dmitri set up his own laboratory in the rooms where he was lodging to study and do chemical experiments, where he continued to study the different characteristics of the known elements. He also at this time had the opportunity to attend the first ever International Congress of Chemistry in Karlsruhe, where he was just completely overwhelmed by how passionately scientists would argue their points of view.
Yes. First exposure to a really broad viewpoints from various scientists.
Yes. And the big question at this conference was, how do we assign each element the proper atomic weight? So kind of back to John Dalton's ideas of like each element has its own atomic weight, but how do we get everybody on the same page as to what each element's atomic weight is?
Yes.
And this was decided at this conference, and it helped unify the scientific community moving forward.
What an exciting conference that must have been.
Yes.
Can you imagine being part of an effort where you're laying down that this is how we are going to evaluate things. This is how we are going to build the foundations of chemistry.
Yeah, these are the rules that we're all the world is going to follow.
Yeah, we are all going to follow the same set of rules. We are so then each of us knows what the other one is talking about.
I can only imagine he was thrilled to even just be there and listen.
Absolutely, such exciting times.
In 1861, Dmitri returned to St. Petersburg, and he took a teaching position at the Technological Institute. He was shocked to find that St. Petersburg was way behind the times when it came to chemistry, especially after all his travelings. He was like,
yes, wait, we have to catch up.
Yeah, so no one in St. Petersburg had even heard of Kirchhoff and Bunsen's spectroscopy experiments. They didn't know about the debate on how to accurately measure atomic weights. And there were even some elements that had been discovered that people had never heard about. So
not yet heard
people
about.
are just way behind the times in St. Petersburg. He also discovered that there was no organic chemistry textbook written in Russian. So he sat down and wrote 500 pages in just 2 months.
Wait a second. What is he translating it from, though?
I don't know if he's translating it. He's just like, this is all
he's
the
just
knowledge
writing
that
down
I
information.
have. Yeah, this is everything we know about these elements. Organic chemistry is obviously the elements that are the kind of the basis of living creatures. So carbon, hydrogen, oxygen, nitrogen. And he's just writing everything that he has learned about these elements of life.
Oh my God.
Yeah.
What an effort and with such speed.
Yes. He's just like, we need this textbook.
We need this. Yes.
This effort earned him the Demidov Prize in the Petersburg Academy of Sciences.
Absolutely well earned. Another big science communicator working on disseminating science to the best of his abilities. Fantastic.
In 1862, due most likely in part to his older sister's meddling, Dmitri got married to a woman named Feozva Nikitichna Leshcheva.
Yes.
Okay.
Yes.
That's as good as it's going to
get. If you got your Russian wrong,
yeah,
I'm sure your audience will forgive you. The audience will forgive you. Yeah, you're doing such a good job with everything else, bringing this beautiful story to us. These are minor points where we should be forgiven.
But the marriage wasn't a happy one, unfortunately.
Because he was already married to science.
Exactly.
He was already married to chemistry.
He was always working. Yeah. And as we mentioned before, he was prone to emotional outbursts that I'm sure his wife did not appreciate.
Yeah. Yeah.
The couple had a son, Vladimir, and a daughter, Olga. But his wife and children would often stay in a different city completely than him so as to not cross paths. So they were basically estranged for most of their marriage.
Okay. She might have found it easier to live near her parents where she had more support or something.
Yeah.
And he, of course, wants to be at the cutting edge of science wherever that's occurring. Yeah.
whatever, away from you. I'm just
Yeah.
getting
This
away
is
from
this is the
you.
thing when you have different life goals, basically,
Hmm.
so
Yes. In contrast to this, though, Dmitri's emotional personality made him a brilliant teacher. He was deeply invested in helping improve Russia's socioeconomic status, and so he started spending a lot of time educating local workers around him. He helped farmers figure out which fertilizers would work best for their crops and how to
oh,
improve milk production.
yeah, probably the triple nitrogen, potassium, and all that we do now. We have
Hmm.
all the three phosphorus, nitrogen, potassium. He must have figured that part out. Like, hey, the plants
Yeah.
need these three elements. Make it happen.
Yeah, apparently he did experiments on his own land of like,
Hmm.
putting different elements and different fertilizers and seeing
Different
how the plants would
proportions.
grow and then
Yes,
spreading that information to the people who needed it.
such dedication. So, what his mom said before she died, search for the scientific truth. He stuck to it.
Oh yeah. Yeah, I read that he basically regarded those last words as sacred from his mom and
Absolutely.
just lived by
Absolutely.
it.
Yeah. Lived by it. Yeah. And made sure that he passed that on to as many people as he could.
Yes.
Such a beautiful person, such a beautiful soul.
He was also one of the first people to suggest building fuel pipelines in Russia and
Mm.
even helped build an oil refinery.
Oh, wow.
Yeah.
Okay.
After completing his doctorate in 1865, he became a full professor at the University of St. Petersburg at just 32 years old.
Hang on. What? He's just completing. You are at a point in the story where he's just completing his doctorate now?
Yes, correct.
Wow.
Isn't that
Wow.
crazy?
Wow. Wow. Wow.
Yeah.
Wow.
Yeah. So now he's a full professor and he's teaching university students who loved him, most of them. He was very enthusiastic and a bit eccentric, and he would often go off on tangents about astrophysics or zoology. That was
Mm.
sometimes confusing in a chemistry lecture, but it made him interesting to listen to. And it also, if you could follow him, helped connect chemistry to the real world.
Yeah, chemistry is not just this isolated little in its own bubble kind of thing. He's connecting it to the universe around him. He's connecting it to the world around him because everything in the world is made up of chemical elements. So it makes perfect sense that he sees chemistry wherever he goes. Makes
Yeah.
makes very good sense.
And so then while he's lecturing, he's like, you know what this reminds me of? It reminds me of, the lactic acid that's produced in your muscles when you're working out. And people
Yes.
sometimes didn't follow that jump. But
Yeah.
if you
Yeah.
did follow it, it was like, wow.
Yeah, when very very brilliant minds, they are able to go from thought to thought to thought, and you
Hmm.
have to pay very close attention to how the monkey branching is happening actually,
Yes.
because it's
Yes.
just going from one branch to another branch of thought, and there is a very clear method to where they are getting, but you have to be agile enough. Your own mind may not be agile enough to keep up with such
Yeah.
genius.
Yeah.
Yeah, that makes sense.
Hi everyone, Aarati here. I hope you're enjoying the podcast. If so, and you wish someone would tell your science story, I founded a science communications company called SciComm, that's SYKOM, that can help. SciComm blends creativity with scientific accuracy to create all types of science communications content, including explainer videos, slide presentations, science writing, and more. We work with academic researchers, tech companies, nonprofits, or really any scientist to help simplify your science. Check us out at scicommer.com. That's SYKOMMER.com. Okay, back to the story. But while he's teaching, he realized once again that there was no textbook that his students could use to study inorganic chemistry this time.
Like iron and all the others, yeah, the
Yeah, all the
iron and
metals and
silver and copper.
gases.
Yeah.
Yeah. So what does he do? Yeah.
Write another book.
Yes. So he begins to write one. But here he starts to run into a problem. So while he's writing this textbook, he starts to try and group the elements into categories so that he can write chapters. So, for example, he writes one chapter on halogens, which At the time, the ones that were known were fluorine, chlorine, bromine, and iodine.
Okay.
All of these chemicals combined with sodium to produce salts, and therefore their name comes from the Greek word halos, which means salt.
Okay.
So all the halogens have similar properties to each other. They fell really nicely into one chapter. He then moved on to alkali metals, which consisted of lithium, sodium, potassium, and rubidium.
Okay.
These all, again, had the same kind of combining power. They could easily combine with hydroxide to form bases like sodium hydroxide, potassium hydroxide. And they could also easily combine with the halogens. Like we said, like you can get sodium chloride, which is table salt. So the alkali metals were another like really clear category that he could write a chapter on. But then after that, he got stuck. So by this time, there about 63 elements that had been identified. And so far, he's covered like 8 of them in his 2 chapters. And then even after accounting for the organic elements that he wrote about before, that still leaves around like 45 to 50 elements that are not forming really obvious groups.
So basically he's looking for a pattern.
Yes.
Where he can combine us and say, here are these fellows who behave the same way. So let's categorize them as such, whatever it is.
Yes. Other scientists had also thought about this question of how to organize the elements. The 2 main ways people used was either by using increasing atomic weight or by the different properties that the elements had, either alone or how they behaved in a reaction. But scientists were like, wouldn't it be great if we had some sort of way to organize the elements that took everything into account? Like we could just look at it and see increasing atomic weight. We could see which ones form salts, which ones were going to explode, which ones were, like, can we organize this in a way that's really easy to figure this out?
Yes.
But no one could really figure out the pattern, because if you looked at the atomic weights of the elements that have similar characteristics, for example, if you take the halogens, fluorine has 19 atomic mass units. Chlorine is 16 units heavier at 35. Bromine is 45 units heavier at 80 atomic mass units. And iodine is 47 units heavier at 127 atomic mass units. So there's like no pattern there.
There's still no pattern. Okay.
Yeah. There was a British scientist, John Newlands, who found that when the elements were arranged according to atomic weight, there seemed to be a repeating pattern every 8 elements, which he called the law of octaves.
Okay.
However, after calcium, which was the 20th element, the pattern fell apart.
Okay.
Now we know that the thing that threw it off was the big group of transition metals that happens in the middle of the periodic table.
Okay. Yes.
But he didn't know that. And so because of that, his ideas were kind of scrapped. Dmitri Mendeleev didn't know about Newland's ideas at all because he was in Russia. So he didn't hear about what was happening in Britain. But he also was like, listen, nature is not that random. There has to be a pattern. And sometimes he thought he could almost see it, but it always just didn't quite work out. Then comes the fateful day of February 17th, 1869. That morning, Dmitri was due to take a train to the city of Tver to give a lecture and take a tour of their cheese-making centers.
Oh, nice.
He's helping the local cheesemakers, because of course he is. He was all packed up and ready to go. Probably, by the way, in suitcases that he made himself, because on top of everything, he had gotten into luggage making when he was studying adhesives at one point in his life.
Wow. Wow. Nothing is a half measure here, huh?
No. However, after breakfast, he went to his study and he started taking notes on the back of a letter, trying again to figure out how to organize the elements. And as he's listing out the group of elements, he's reminded of his favorite card game, Solitaire. We used to play that all the time.
Yes.
It was like one of the games. We had Tetris and Solitaire, and I think Spider on our computer PC at home in the 90s.
PCs ever. Yes, you're dating yourself, Aarati, when you say all that.
I know. Not as old as him though. What is this? What did I say?
1869.
1869? They were playing solitaire. It's classic game.
Yes.
If you haven't played solitaire, basically you take the cards and organize them according to their suit, starting with
Yes.
ace and going up to the king. And so he's like, maybe that's what I need to do. I need to kind of organize these elements based on their suit or their properties. How can I do that? So he told the carriage driver who was waiting outside to take him to the train that he would take the afternoon train instead and come
Mm.
back later. He then took some blank cards, and on each card, he wrote down an element and its
Mm.
atomic weight and its properties. And he started to play around with them, just like playing
Mm.
cards. But he still couldn't quite get it to work out. He ended up missing the afternoon train too. And as night fell, Dmitri finally became exhausted and he laid his head down on his desk and he fell asleep. Dmitri later said, quote, I saw in a dream a table where all the elements fell into place as required.
Oh,
Awakening,
wow.
I immediately wrote it down on a piece of paper, end quote.
This is exactly like Kekulé. I don't know if I'm saying the name right, but August Kekulé, he's the one until then, all chemical structures, when you think of a molecule that contains carbon, you always thought of carbon as a chain. And he's the one who thought of carbon as a ring. And he got that idea from a dream, and some unkind people, or maybe more accurate people, I don't know, it depends on your point of view, think he was in an opium haze when he got this idea.
Oh, interesting.
But he dreamt of snakes putting their tail into their mouth.
Oh,
And
okay.
when he woke up, he thought of carbon is not necessarily a chain, but
Yes.
a carbon can be arranged as a ring. And he's the one who came up with the concept of a benzene ring.
Oh, wow. I hadn't heard
So
this
this,
story. That's super
oh my
cool.
God. Yeah, it's a very cool one. It's like a fundamental structural change in the way you think about molecules that contain carbon, because it's not, chain versus ring. The whole thing changes. It becomes organic chemistry. There's a huge, entirely
Yeah.
different class.
Yeah, I think in organic chemistry we had like an entire class on benzene rings just dedicated, like
Yes.
chapter 4, benzene rings.
Yes.
That's what we're
So
studying this time. Yeah.
that's when I learned about it. When I was first introduced to benzene rings, I was introduced to the name August Kekulé, although you know me and my pronunciations, they're all very wrong.
Oh, that's
But
really cool
but
though. Yeah.
yes, but Dimitri sounds exactly like that, where he's got it. He's really got it, but his brain is too exhausted. And then once he falls asleep, his subconscious puts the pieces together, or like a bird's eye view kind of thing, and then it falls into place.
Yeah. And something about relaxing the brain also. I feel like,
Relaxing and giving distance. You view that same problem from a bit of a distance, and immediately things fall into place. So Dimitri has his breakthrough now with.
yes, in a dream. Basically, what he realized was that if he listed all the elements in order of atomic weight, their
Mhm.
properties repeated in periodic intervals. He therefore wrote all the elements down in a table that he called the periodic table of elements.
Woohoo! Periodic
Yep.
table. Yes, yes.
He published the table 2 weeks later in an article called A Suggested System of the Elements. And Dmitri was convinced that he had cracked the code because not only were all the elements grouped according to their characteristics and all the
Mhm.
elements were in order of increasing atomic weight, but
Mhm.
also other patterns that people hadn't really considered too strongly were emerging. And so for this point in the story, I thought it may be useful if you have it handy to look at a periodic table. And that's why
Let
I
me
kept
see.
that
Let me
little
see.
book next to
Okay.
you.
Oh, okay.
On the
Okay.
back
Okay.
cover, on the very back
Okay.
cover, there
Okay.
is a handy dandy
Ooh.
periodic table.
Yeah.
Yeah. So there you go. I'll put one up on YouTube for people who are listening there so that they can
Okay.
follow along. But some of the patterns that he saw were emerging was, for example, the metal alkalis, which is the lithium, sodium, potassium, and rubidium column on the left-hand side.
Uh-huh.
They could all form a single bond to another element. But in the next column, which starts with beryllium and then magnesium, calcium, they could all have 2 bonds.
Correct.
The next column starting with boron could have 3 bonds.
Yes.
And then the next column starting with carbon could have 4.
Okay.
And then it started to go back down again. So it went 1 bond, 2, 3, 4, and then 3, 2, 1.
Oh, this is amazing.
So he was like, I'm totally on the right track. Like,
Yes,
you know.
absolutely. Strong validation right there. Yes.
Remarkably, Dmitri also found holes in his table. So, for example, according to his organization, Dmitri thought that there should be an element just below aluminum on the table, which would have an atomic weight of about 68 and should have similar properties to aluminum, but no one had discovered it yet.
Okay.
So when he arranged his table, there was nothing to put in that spot.
Got it.
But he said there should be, according to my table, there should be.
Wow.
And a side note that I thought you specifically would be interested in, he named this unknown element Aka aluminum. And he had 2 other similarly predicted elements, Aka boron and Aka silicon. And that word Aka came from the Sanskrit word for one.
Aka.
Yeah, for one place below aluminum.
One place below. Oh, wow. Oh my goodness. How did he know Sanskrit? How did he come up with that?
I asked that question, and apparently it's because Sanskrit was a highly respected language at the time, especially among scientists. And European scientists who had studied Sanskrit found it to be very highly systematic and rules-based, which was very appealing to any scientist. The reason that Dmitri specifically used it was that it was not as overused as Latin and Greek were in science nomenclature.
He had an allergy to those languages right from his childhood. It's like, I am going to go to this completely different continent, to a completely different language.
Exactly.
But, this is so cool. And it is sad in a way that it has become an ancient language now, because it is truly remarkable. And the amount of wisdom that is lost because we have lost the language of Sanskrit, and it is no longer a commonly taught language. It is quite astonishing.
I think my aunt, your sister, was studying Sanskrit at one point, or is she still studying it?
Yes, she still studies it, yes, and she teaches it as well.
I've heard her talk about how complex and deep the language is.
You have like 8 different words that would all flatten out to the word mind in English. But then in Sanskrit, there would be connotations to memory or to the subconscious or to the existence or some things like that, intellect like that. They touch on different flavors.
Yeah. So I thought that was a fun little tidbit for why he named those things. So there were a few other holes and discrepancies in his table, but Dmitri was very sure that he was right. However, many other scientists were critical of his so-called periodic law because they were like, how can you be so sure of something when there are holes? You say this element has yet to be discovered, or this property that this element seems to have because it falls in this column is yet to be explained. But then how can you make a law about something that you don't have these answers to?
Right.
Then in August 1875, a French scientist named Paul Lecoq de Boisbaudran announced that he had discovered a new element, which he called gallium.
Ooh, that filled the hole in the Aka aluminum was filled by gallium.
Yes. So the word gallium came from the Latin word gallia for France. And gallium had an atomic weight of 69 and had the same properties as Dmitri had predicted Aka aluminum would have.
Ooh. So now it's like the unknown is now validating what we know already.
Yes. And as other scientists brought more information and discovered more elements and new properties, Dmitri's table largely proved to be correct. He did have to make some small tweaks here and there, but overall, he had really hit the nail on the head.
Fantastic.
And although that would probably be it for most of us, we would probably just spend the rest of our lives, making small
Like,
tweaks to our amazing
yes, I have
table.
fulfilled the purpose of my life. I have validated my existence here.
Yeah, we'd just be sitting
Done
back
something
collecting
good.
awards, like, we did it.
Giving lectures, humble bragging.
Yeah, exactly. But Dmitri did not do that. Just 2 years after publishing his table, he switched his scientific focus entirely to studying the behavior of gases at various pressures.
Wow.
This work was funded by the Emperor's Russian Technical Society, as this was of particular interest to the military. However, Dmitri was not very successful in this area. He actually didn't make a great experimental scientist, I have to say. So many times he didn't measure things out as precisely as he should have, or he jumped to conclusions too fast. And it was like his mind was just constantly jumping around, which was really great for coming up with really novel, out-of-the-box ideas like the periodic table.
Yes.
But it wasn't great when you needed to rigorously test and focus.
That method and that discipline is required.
Yeah, he got bored with stuff like that really fast. Or was just like, good enough, really fast.
Absolutely.
The government started to lose faith in his work, and Dmitri himself soon stopped accepting their funding because he just wanted to study other things. And he was like, in good conscience, I cannot, accept your money.
It's like it was not interesting to him at all. So
yeah. Then in 1876, at the age of 42, Dmitri met a woman named Anna Ivanovna Popova. Even though he was still married, he started courting Anna and soon became obsessed with her. She was a young artist studying at the Imperial Academy of Arts, and she also had a very romantic and emotional personality, which apparently meshed really well with Dmitri's equally dramatic personality.
Okay.
Apparently, Dmitri threatened to kill himself if she did not agree to marry him.
But did she know he was married already?
I think she might have known, but I'm not 100% sure of like when she knew or how that happened. But yeah, apparently he threatened to kill himself if she didn't agree to marry him. And when I first read that, I was like, well, that's a red flag. But now after learning about him and his dramatic personality, I kind of think he was just very prone to these like Shakespearean levels of drama.
Yes.
And, like,
outbursts. He was that kind of, that was his personality.
Yes. And she also probably thought it was highly romantic. Like, I will die for you. And she's like, oh, my heart, So it's like, okay.
Each to his own, man.
Yes.
in today's world, I would really consider that to be emotional manipulation. And if any young lady came to me and told me that this is what my beau is threatening me with, I would advise her to tell him to go ahead and bring the popcorn.
Like that Tom Sawyer thing. I'll die and then they'll be sorry.
And then they'll be sorry, but then you have lost your audience for the dramatics that you thrive on.
Yeah, but I think she also was like highly dramatic and was like, oh my God, like, no.
Amazing. He loves me.
He loves me so much.
She probably took it as a proof of his love.
Probably.
Okay.
But in order to get married to Anna, he first had to get divorced from his first wife, whom he was estranged from. This topic of divorce was heavily frowned upon in Orthodox Russia. And Dmitri made it even worse by marrying Anna 1 month before his divorce was actually finalized.
Man.
And even then, the Orthodox Church had a 7-year waiting period before a divorced person could remarry.
Oh, wow. And he marries. Not only does he not even, it's overlapping. Instead of having a 7-year separation period between two marriages, they in fact overlap. Oh, excellent. Excellent. This must really boost his popularity with the powers that be there.
So even after the divorce was finalized, Dmitri was considered a bigamist, technically.
Correct. Because obviously he's got it all lined up beforehand.
It caused a huge scandal and public uproar and impacted his career as well. The Russian Academy of Sciences refused to accept him as a member because of the controversy. However, Dmitri and Anna were happy together and they had 4 children, including a set of twins.
Okay.
I was like, this all could have been avoided if that meddling sister.
If the meddling sister had not meddled to begin with, he could have found his
Yes.
true love much later in life.
The first wife would not have been unhappy.
Correct.
He would have been happier. Everything would have worked out.
Yes.
Some people just take some time. It took him until the age of 42, to
Yes.
find the
That
person
which is very young in by today's standards.
As he got older, Dmitri's interests started to get broader. In 1887, he flew a hot air balloon by himself to view a
Oh,
solar eclipse, even though he had never flown a balloon before and didn't know how to land it.
oh, no way. No
Yeah.
way. I can see this. He's so excited. He hops on, and then after he gets what he wants out of it, he's like, oh, oops, I actually need to find a way to come back down to earth.
How do
Oh,
I do
wow.
this? I'll figure it out.
Yes, how do I do this? Exactly.
In 1890, he retired from St. Petersburg University
Hmm.
and he got into shipbuilding and designed the world's first Arctic icebreaker, the Yermark, for the Imperial Russian Navy, which had a strengthened hull shape that could ride over and crush ice.
Oh, wow. So, periodic table, luggage maker, now
Mm-hmm.
shipbuilder.
Yes.
Okay.
Then in 1893, he was appointed to be the director of the Bureau of Weights and Measurements, which works to provide a single coherent system of measurements throughout the world. So everybody
Yes.
has the same standard for an inch or a pound or
Yes.
whatever.
Yes. Yeah. Standardize it. Correct.
With this position, Dmitri was able to introduce the metric system to Russia.
Wow. Two textbooks, now the metric system, the periodic. How much can one person do in one lifetime? Wow.
And he also continued to work on ways to industrialize Russia and improve agriculture. However, he did have some strong and incorrect notions on science as it moved forward. He completely rejected the idea of electrons because he thought there couldn't be anything smaller than atoms. Atoms
Okay.
were the smallest thing.
The smallest thing possible. Got
Yeah.
it. Mm-hmm.
He distrusted the discovery of X rays, who we talked about, William Röntgen, in a previous episode, who discovered X rays. But he didn't believe that discovery because that implied that there was some invisible thing that could pass through solid matter, which is something that he had worked very hard to discredit. That
Yes.
there were
Okay.
like invisible
Yeah.
ethers or like, invisible fluids. He was like, no.
So he's just walked away from all of that thought process. So now no, don't take me back there. Yes.
Yes.
Mm-hmm.
And he was opposed to the idea of radioactivity, which for him was too close to alchemy, with chemists saying that certain elements could decay or transform into another element.
Oh, yes.
And that was too close to those old notions of transmutation. And
yeah, it's basically he's throwing the baby out with the bathwater in these cases. Mm-hmm.
Yes. Okay, so there's one kind of last chapter, I would say, to Dmitri's life. So in 1905, Dmitri was elected to the Royal Swedish Academy of Sciences and received 3 nominations for the Nobel Prize in Chemistry for his work on the periodic table.
Oh, wow.
However, that year, the prize went to Adolf van Baer for synthesizing indigo dye, which was enormously valuable and had been difficult to obtain, and for his work on hydroaromatic compounds.
Okay. So the focus was different on that particular year. Okay.
Yeah. In 1906, Dmitri received 4 nominations and was actually recommended by the committee to the Academy, which usually means that that's the winner. The committee has chosen a winner. The Academy just has to approve the committee's decision. However, in this case, a member of the Academy, Peter Classen, unexpectedly stood up and said that he thought another chemist, Henry Moisen, who isolated fluorine, which was a highly toxic and reactive gas, and had worked on developing a high temperature electric arc furnace, should be the one to win the prize.
I see.
And then Svante Arrhenius, who was also on the committee, also spoke out against Dmitri's nomination, saying that the discovery of the periodic table, while it was amazing, was over 30 years old and so therefore too dated for the Nobel Prize, which was supposed to go to more recent discoveries.
Which is not true, actually. if I'm not mistaken, Barbara McClintock discovered transposons much earlier. Their value came to light and their practical applications came to light much later.
Yeah.
And so then she got awarded the Nobel Prize. But if I'm not mistaken, I have to go check that out. Yeah, I think that's more politics. If you are against something, you find a way to derail
Yeah.
the nomination.
I remember from our very first episode, Alfred Nobel, he had something in his will that said that the Nobel Prize was supposed to go to the person who had created the most benefit for mankind in the previous year. And so I feel like Svante Arrhenius probably really relied on that phrase. And so I think you can make a case for, yeah, it was discovered many years ago, but today is when we found a really good application for it, or today is
That's
where we
right.
realized its full potential, and we should give the award to this person, even though they
Yeah.
made the discovery many years ago. But he used it in the opposite way. Dmitri was nominated again in 1907, but was again
Hmm.
rejected by Arrhenius. So, in the end,
Okay.
Dmitri never actually won the Nobel Prize, although he was nominated for it 3 times.
Sometimes you can't fight the system
Yep.
for whatever reason. It maybe it was his emotional nature. Maybe it was the fact that he was considered a bigamist. Maybe it was the fact that he was Russian. You never know what it was.
Who knows? Yeah.
I mean, the world recognizes him today as the father of the periodic table. Nobody can take that away from him.
And I think I did actually read an anecdote now that I'm thinking about it in my research that Dmitri might have yelled at Svante Arrhenius at some point during
There
some
you go.
emotional
There you go.
outburst.
Yeah, it
And
is some sort of
yeah,
a, yeah,
and there was like
absolutely.
some sort of personal vendetta there.
There is a personal vendetta going
Yeah.
on there.
Or was
Yeah,
highly critical
that's,
of his work or something.
yeah. This goes to show you that intelligence and wisdom do not necessarily go hand in hand. There are a lot of intelligent people who still hold on to personal little petty vendettas
Mm-hmm.
and can't rise above that. I don't
Yeah.
have the wisdom to rise above little petty grudges.
Yeah. Because if you think about it, it is kind of shocking that the guy who organized the periodic table, which is in every chemistry classroom in the entire world, has not won the Nobel Prize.
Yeah, and it has completely defined how we think about our chemicals today, how we organize it, how we look at them, how we classify them into different families or based on their properties or their bonds or whatever. And that,
Mm-hmm.
seminal work did not get recognized by the Nobel Committee. It actually speaks badly of the committee rather than of the scientist who discovered the periodic table. The Nobel Committee
Yes.
looks bad when they don't recognize the right work. The Nobel Prize still has a very big value because this doesn't happen as often. So you really need to, in order to have that weight for the Nobel Prize itself, it should be awarded appropriately. Otherwise, the prize itself becomes less meaningful.
Yes. But I don't think Dmitri really knew about the last nomination, the one in 1907, because in January 1907, he contracted influenza and died at the age of 72. Years after his death, his name was given to the Mendeleev Institute for Metrology in St. Petersburg with a monument that has a statue and a depiction of his periodic table. In 1955, element 101 was discovered and named Mendelevium in his honor.
Mm-hmm. Nice.
And ironically, it is radioactive. So,
That is ironical. That is truly ironical.
yes.
That is life
Yep.
slaps you back, man.
Yep. There's also apparently a large crater on the moon that is named after him.
Mhm.
And the good old Google Doodle in 2016 celebrated his 182nd birthday.
Whoa,
And that is the story
nice.
of Dmitri Mendeleev.
It doesn't matter whether he got the Nobel Prize or not because the world recognizes and appreciates the structure of the periodic table.
Yes.
Nobody can take away from that. I talked about Feynman in a previous episode where he was given the Nobel Prize, and
Mm-hmm.
he said exactly the same thing. He said, a bunch of people who pat themselves on their back and they decide that they are the arbiters of who did good work and who did not. Who
Mm-hmm.
appointed them to be the decision makers? And I don't value that. I don't value them as the decision makers of what true science is or what true benefits to humanity is. So
Yeah.
if a bunch of self-appointed people say you're good, what does that mean? It's the science. It's your bond of the scientist and the science that cannot be
Yeah.
broken.
Yeah. In that spirit, these two inconsequential hosts of the Smart Tea podcast have bestowed the honor of the 50th episode on him. So,
Yes.
you
So
know,
we give him
we give
we
him,
give the periodic
yeah,
table its due. And he is a huge deal. The periodic
yes,
table is a huge deal. The world
yeah,
will always be appreciative. It's a permanent part of the way we look at chemistry now.
yeah. Thanks for listening. If you have a suggestion for a story we should cover or thoughts you want to share about an episode, reach out to us at smartteapodcast.com. You can follow us on Instagram, TikTok, and Blue Sky at Smart Tea Podcast, and listen to us on Spotify, Apple Podcasts, YouTube, or wherever you get your podcasts. And leave us a rating or comment. It helps us grow. New episodes are released every other Wednesday. See you next time.